If you watched my previous video on conditional formatting in the if statement, you'd recognize this spreadsheet where I'm highlighting snake eyes and sevens as we go. I've got like 998 rolls of 2 dice being simulated with random numbers. I'm going to delete the snake eyes column from before. All right, let's talk about the distribution of these different sums that can occur. And what we're going to do is we're going to count how many occurred. Maybe even get the probability. So let's get the number of rolls. How many times did I actually roll and get a number? There's a formula, or a function actually, called count. And what that allows you to do is actually counts how many values you have. I'm going to highlight all of my data, all of it, all the way down to row 1000. And my count function is telling me I have 998 rolls, so I was correct. What happens if I delete some of the content in a row? Well, I have 997 rolls. And so my count function is working. So that's count, and then what do you want to count? And a lot of people ask me, well, why didn't you include just the whole column? I can. If I do C1 all the way down, it still says 998 because the word sum is not a value. All right, so I could actually have done the entire column. I still have 998 rolls because the word sum is not a value. If I were to accidentally put a value in there, now it thinks I have 999 rolls, which I don't. I have 998. All right, well, how many of those rolls are a 6 or a 1 or a 7 or an 8 or whatever? Well, none of them are 1, but you get my point. So let's take a look here at the distribution of these different outputs or outcomes that can happen. So we can sum to 2, we can sum to 3, we can sum to 4, and we can sum all the way to 12. And what we're going to do now is we're going to count how many times we got each of those things. So let's just make this prettier, maybe get this a little bit closer over here. Let's count how many times we got snake eyes. So we're going to use a very similar function to count. Instead of count, we're going to say count if. Now, if you watch my previous video, I talked about the if function. This is very similar. We're going to count the cells only if they're equal to 2. So I'll say count if, and I need to give it a range. Well, my range is the column C. This is where I'm looking things up. You could do just any range, you select just some cells or whatever. But for my example here, I'm counting the whole thing. Well, I only want to count them if they're equal to 2. And the criteria here for the COUNTIF function has to be put in quotation marks. It's just one of those things that you have to follow those rules. So I want to say if it's equal to 2, then count how many of them are equal to 2. Well, right now, 23 of them are equal to 2. But because my roles change, because they're randomized, every single time I change my spreadsheet, which if you're wondering how it's changing, I'm just hitting delete on a blank cell, I'm getting 21, 22, 23, 25. So that's changing. Now, I don't necessarily have to say equal to 2. I could have actually said equal to this cell over here. Let's take a look and see how we can do that. I wonder if I can actually just click on this one. Does that work? It did work. And that's what you can do too with these sort of, if you're working in a program, you're not going to break anything. Just try stuff out. So what did I just do? Well, I just said, okay, forget the whole quotation mark equal to 2 thing. I said, count it if it's equal to whatever's in this cell over here. Now, if I accidentally change this to a 4, it's going to count all of the cells that equal to 4, which apparently there's 96 of them. But I don't want 4, I want 2. And this is now going to allow me to drag my formula down and copy that formula. And let's just take a look at the 7s. Just make sure CC, which is column C, is it equal to E10? So E10 is 7. Good. So it's counting how many of them are equal to 2, 3, 4, all the way to 12. And take a look at this distribution. It's actually pretty awesome. So the probability of rolling a 7 is the highest one. And we'd get a 177 over 993% chance. As a matter of fact, let's talk about that percent. Oh, this is getting exciting. Percent probability. Well, let's calculate the percent probability. So I want to say the percent probability is equal to this cell divided by this cell right here. And I'm not going to autofill. And that's my percent probability of rolling snake eyes. Let's actually turn it into a percent and get rid of the nasty decimals. So I have apparently a rounded to 3% chance of getting snake eyes. And we've been dragging down some formulas before, but watch what happens if I drag this formula down now. I'm going to drag this formula down for all of them. And I get some Strange values. What is going on here? Why didn't dragging it down work this time? Well, it's got something to do with relative versus absolute references. Blah, blah, blah. Just tell me what's happening, Brash. Well, when we drag things down, it's trying to modify the equation for us. So E5, and then I've got E6, E7, and so it knows to look at the one below it. And when I drag this function down, and my denominator is E3, it's going to try and use E4 for the next denominator. Well, there's nothing in there, so I get a division of 0. And then it's going to try to use E5 for the next denominator, which is 2. So I'm only dividing by 2. I don't want to be dividing by these. I want to stick to 998. There's a trick for that. In your equation or in your formula, you can do it either up at the bar or right here. If you put a $sign in front of something, it means don't change it when I'm dragging things around. So if I put a $sign in front of the row 3, it means, hey, listen, don't change E3 when I drag this formula down. So if I drag my formula down now, I don't get messed up numbers. I'm dividing by, look over here as I go down. So F5 divided by E3, F6 divided by E3, 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 E3. So it didn't drag it down, it didn't change it because I put that $sign in front of it. The $sign is just like a code. It's just somebody decided, let's use $sign for that. And now we can really see the percentage probability distribution where 7, apparently, according to my experimental probability, sums to 7 17% of the time. And if I were to change the values in here, I'm changing them. I got 14 was my lowest so far. 18 is my highest so far. And 19, I got a 19. 20, there we go, 20%. And I'm getting some pretty interesting distributions. Last but not least, we can graph this. We could graph this distribution. I could take these values and I could insert a chart. Oh, I'm just getting so excited now. And I could get like a bar chart or a line graph. Look at this distribution. Isn't that gorgeous? Look at that. Let's turn it into a bar graph because it's discrete values. And look at that. Look at that. We get a normal distribution, close to normal distribution, because you can only get snake eyes with a 1 and a 1. You can only get a 12 with a 6 and a 6. But adding to 7 is the highest probability when you roll 2 dice. Nice.